Hello, everybody. Welcome back to another ACP meeting. This meeting is going to introduce ACP-181, written by Cam Schultz. The proposal, he's going to explain more about this, but in essence, this ACP was introduced to introduce epoching to the P chain, so the ProposerVM. And as we all know, the P chain is the home of L1 validator operations on Avalanche, and epoching will make the user experience for adding and removing validators a whole lot smoother by enabling the VMs to prefetch validators based on the epoch that the chain is currently on. So I'm going to let Cam go through the ACP, but if you have any questions, feel free to leave them in the chat, and at the end, we'll have time for a live Q&A.
Cool. Thanks, Meg. Yeah, as Meg described, this ACP introduces a specification for introducing a way or an epoch view of the P chain. So just to explain that terminology a little bit, where this ACP is not proposing that we epoch the P chain itself within the P chain's VM, but rather provide a mechanism for any VM that needs to reference the state of the P chain to do so through this sort of epoch view. The main motivation, or like the primary use case and biggest unlock that this ACP will enable, which we'll dig into the specifics on this call, is improved ICM verification, both in terms of reliability of actually producing an ICM message and then verifying it on a separate chain, as well as the cost to verify that message. Yeah, the functional unlock is that, or the functional reason behind that is that at present, the P chain state must be fetched at execution time. And that's because due to the mechanics of the way the ProposerVM works right now, we don't actually know what P chain height needs to be used to verify an ICM message until we actually go to build that block. With the introduction of epochs, we unlock the ability to know that validator set ahead of block building time for any given block, which allows us to fetch that validator set asynchronously and optimize out that validator set retrieval at block execution time. Yeah, so diving into the specification a little bit, basically we define an epoch as any contiguous range of blocks that share an epoch number, an epoch P chain height, and then an epoch start time. So for all blocks within that range, this epoch P chain height is going to remain fixed, and then which is the primary piece of information that is used for ICM verification. And then this additional metadata, epoch number and epoch start time, is we'll get into that in just a second, but that's used to determine when the epoch actually increments. Yeah, so an epoch is, or the main parameter for defining the epoch is its duration D, which is provided via or at least in this proposal, is provided by a required network upgrade, and that's fixed and hard coded into the source code, Avalanche Go source code, until it's updated by a future network upgrade. But the way epochs advance is as the first, or if you're in currently in epoch n, or E of n is the notation that we've used in this ACP. That epoch is sealed by the first block with a timestamp greater than or equal to the starting time of that epoch plus that hard-coded D. The second piece of epoch sealing definition is that we define the sealing block to be a member of the epoch it seals. And then once you've produced a sealing block, the next block after that sealing block advances the epoch. It advances the epoch by setting the epoch p-chain height of the new epoch to the p-chain height that's embedded in the sealing block of the previous epoch. And it also sets the starting time of the next epoch to that current block's timestamp, and then increments the epoch number by 1. Yeah, that's all kind of. There's a lot of kind of subtle details in the actual specification of epoch sealing and how epochs are sealed and how they advance. But I think the upshot is captured in, or there's a couple of nice properties that fall out of this specification. First is that since an epoch start time is set to the timestamp of the sealing block of the previous epoch, all epochs are guaranteed to have a duration of at least D. So if you have a use case that depends on the validator set being fixed for a certain amount of time, you are guaranteed to have that. You're guaranteed to have that for at least this duration D. One caveat there is that since the sealing block of an epoch is defined to be a member of the epoch that it seals, the actual realized duration of an epoch, while it's guaranteed to be at least D, it may be unbounded. There's no upper bound to the actual duration. And the reason for that is suppose there's a long gap of time in between a block that's produced just before this duration elapses, and say the next block that's produced is however far in the future. That next block is still going to be a member of epoch n, even though it's arbitrarily further ahead in the future than this duration. Then another nice property one nice property of this epoching scheme is that when any given block is produced, the validator set for the next block is known at that time. So to see that, suppose there's a new block, this B of M, and it can either seal its epoch or it won't seal its epoch. If it seals its epoch, then the next block will begin a new epoch, and and that next block will use the validator set at the sealing block's p-chain height. If instead this block B of M does not seal the epoch, then it just continues to use the p-chain epoch height of that current epoch. So in both scenarios, when you produce block B of M, you know what the validator set for the next block B of M plus 1 is going to be. Yeah, on to use cases. So most of these use cases or all of these use cases that are enumerated right now in the ACP are focused on ICM, targeting an implementation of this ACP within the ProposerVM. Yeah, there are other potential applications of p-chain epoch views if they were to be implemented at the consensus layer, for instance. But for the purposes of this introductory call, won't dive too deep into that unless anybody else on the call has a specific use case in mind that they'd like to elaborate on. But yeah, I'll just stick to ICM related use cases. Yeah, so as I mentioned earlier, at present, in order to verify an ICM message on chain, the block executor, whether it's the block builder or if the validator is just verifying a block, in either case, the signing L1's validator set must be retrieved at block execution time by traversing backward from the current p-chain height to the p-chain height provided by the ProposerVM. And that height that's provided by the ProposerVM is based on a sliding time window. So because that sliding window is time-based, you can't tell until you actually go to build the block and reference that sliding time window which p-chain height you're going to use. Yeah, this traversal depth, due to that uncertainty, that traversal depth is highly variable. So to account for the worst case, VM implementations charge a large fixed amount of gas or whatever equivalent is to perform this verification. Subnet EVM and Core ETH, for example, the C chain and any Avalanche EVM based L1 charges a fixed gas cost of 200,000 gas to perform an ICM verification, and then on top of that, there are the gas charged scales with the number of signatures that need to be verified, as well as the actual size of the payload, of the ICM payload. So with the introduction of epochs, since you know the validator set ahead of time, and you know when those validator sets are going to refresh based on the epoch duration, you can, instead of having to wait until block execution time to get the p-chain height that's going to be used to verify an ICM message, you can fetch the validator set at that p-chain height ahead of time, asynchronous from block execution, which allows us to not have to consider this highly variable traversal depth and validator retrieval at block execution time, which will allow us to reduce the verification gas cost by a significant amount. The exact numbers are still need to be benchmarked and produced, but conservatively reducing the fixed term of the verification cost by half, perhaps even more, seems realistic. Then in terms of another use case is improved relayer reliability. So for just to quickly summarize how ICM messages are used to deliver or to send cross-chain messages. That whole flow relies on an off-chain relayer component that collects signatures from the validator set of the signing L1, packages those individual BLS signatures into an ICM message, and then delivers that ICM message embedded into a transaction to the destination chain. So there's a lot of steps that have to occur off chain that are asynchronous from either chain, either the source or destination chain's execution. And at present, if the validator set changes at any point along the way, while requesting signatures, constructing the transaction, and then issuing the transaction, then ICM message verification may fail. Epochs improve upon this by providing that guarantee that the p-chain height used to verify an ICM message is going to remain fixed for a certain duration of time. That's importantly predictable to off-chain relayers. Based on the specification above, off-chain relayers could derive epoch boundaries they could derive the epoch boundaries for a given chain by mapping the actual on-chain or the actual block production to the epoch advancement rules that are specified above in this ACP, or we could also very easily expose this epoch information via an API. Yeah, in either case, relayers would have all of the information they need to decide which validator set to query, whether it's the validator set of a given epoch or the current epoch, or if we're very near the boundary of, or the point where an epoch is about to expire, or advance rather, then they could query the validator set of the next epoch. Yeah. Further on the VM side, VMs could relax verification rules to allow ICM messages to be verified against not only the current epoch, but the previous epoch as a fallback, which would completely eliminate that class of epoch boundary edge cases. Yeah, are there any questions so far about the specification or use cases?
So I have a question about like so for the validator sets used for like block building. So for like the actual proposer list for who is the block proposer, is that also used or expected to be used for with these epochs, or is the epoching specifically just for the like inner VM to the proposer VM?
Right now, the reference implementation only targets the inner VM, and yeah, all of these use cases that are enumerated here. This is not a complete or an exhaustive list by any means, but all the use cases are focused on applications within an inner VM.
I think that's a interesting question as to the scope of this ACP, though. If there are further use cases that are unlocked by also using the epoch view for consensus and block building, then what are the additional edge cases and complexities that would need to be accounted for, or what other design considerations need to be made?
I do have one question that I actually wrote as an FAQ, and it's, what is the actual proposed duration of the epochs? Do we have any kind of like, how will we make that decision, and what would make an ideal epoch length?
The exact duration boils down, or it depends on the specific use cases. So for an inter-VM use case or an inter-VM implementation that is targeted towards ICM verification use cases, we want to have a duration that's frequent enough that the validator set at a given p-chain epoch height is not too stale relative to the current p-chain tip, but we want a duration that's long enough that we can still realize the advantages of fetching validator sets asynchronously. So if it's too often, then we're still paying a lot of that computational cost. So that translates to something on 30 seconds to a minute is a ballpark figure that seems to make sense in conversations. Obviously, we would want to benchmark that and have more formal sort of justification for whatever duration is provided. But that's all to say that it's going to be largely guided by the actual use case that is targeted by this ACP. So yeah, if we also wanted to apply this ACP to the consensus layer, there's going to be a host of different considerations that would need to be made. One related example is that with simplex VMs, which is some under development right now, still highly experimental, but simplex consensus, our Avalanche implementation also has a notion of epochs to determine what the validator set, or to inject validator set changes at consensus time. And we determined that this epoch this epoch specification, since it's block production based, rather than, or it's contingent on block production within the L1 rather than on the P chain, was not appropriate for simplex consensus. So could be a notion of this kind of like layered epochs, where you have epochs that are applied in one way or defined in a slightly different way at the consensus level, and then epochs that are defined in a different way within the VM itself. Yeah, go ahead, Yakov.
Yeah, just like to say things in the most accurate way possible. So in my opinion, the way to present it is that if you're ICM and you look at epochs, you see epochs that either ProposerVM or Simplex presents to you in a way that you need to consume. However, Simplex itself will have epochs. Epoch is just a terminology, right? I mean, you can have like two different things, and each thing can be called an epoch, just in different domains. So the Simplex epochs will be completely unrelated to the epochs that ICM consume, basically.
Yeah, thank you. But yeah, back to the original question. If like within ProposerVM chain, we wanted to apply this p-chain epoch views at the consensus layer, there may be different requirements and different use cases that would inform the actual duration that we choose.
Okay, and then just a follow-up, if we're just talking about the p-chain and like validator set control, and let's say like the epoch is set to a minute, or yeah, just a minute for the example, does that mean every minute, once the epoch is closed and the new epoch is open, there will be like however many pending L1 validator transition functions waiting, and will they all like try to hit the P chain at the same time then? Is that going to be an issue, or like?
No, because the P chain itself is not, like, epochs are not being implemented within the platform or the P chain VM. So there's this sort of queuing shouldn't apply to.
So is it something like the transactions still hit the P chain whenever they are broadcast, but the epoch is controlling some tertiary variable that is actually going to be fed to like the relayer requesting the validator set from the P chain, or like, I guess I'm just confused on how the transactions to change validator's weight or like add an L1 validator will still be actively like accepted and like changing the state of the P chain, while the epoch will be controlling what is considered the current validator set.
Yeah, so the P chain state updates are unaffected by this ACP. All this ACP is doing is introducing a mechanism or specifying how to view the P chain state, like a structured way to view the P chain state at a given point for a given duration from the reference point of the VM of some other chain, of a ProposerVM chain in the reference implementation example. Gets a little confusing because the P chain itself is also a ProposerVM chain, so the P chain's view of itself will be subject to this epoching scheme, but P chain's state will still, nothing has changed there in terms of how the P chain, in terms of how transactions are issued on the P chain.
I see. Okay, thank you.
Cool. Yeah, we talked about use cases, backwards compatibility. I mentioned that this would require a network upgrade. We have a reference implementation at the boundary between ProposerVM and the inner VM that everybody that is available and ready to look at. I guess some security considerations. As I mentioned before, epochs may have a unbounded realized duration, even though the duration of an epoch is set as a network upgrade parameter. So as a result, it's possible for a given block's P chain epoch height to be arbitrarily far behind the tip of the P chain. Going back to the previous example, if you have a block that's produced a long time after the given epoch is set to expire, that block is still going to use the P chain epoch height of the current epoch. It'll seal the epoch, but it'll still use the P chain block of the epoch height of the current epoch, which may be arbitrarily far behind the tip of the P chain. In terms of the validity of ICM verification, this has no effect this makes no difference since the validator set at the P chain epoch height, regardless of how old that P chain epoch height may be, should still exist in memory. But there's a couple of considerations that should be made. One affects the ability to actually produce an ICM message. As validators exit the validator set, the operator may shut down their node, which may make it unavailable for serving BLS signature requests. So if you're trying to construct an ICM message at a p-chain epoch height that's very far in the past, there's no guarantee that you'll actually be able to, or it's less likely that you'll be able to actually produce or fetch those individual BLS signatures. And then on the verification side, even though the ICM message is valid, it doesn't represent an attestation of the current validator set. It represents an attestation by a validator set at the p-chain epoch height, which may or may not represent active stake. So those are two considerations that should be made if you have a very long epoch. Both of these scenarios only apply to like low traffic chains where you would see where there may be a long time in between blocks, and they can both be mitigated by just producing a block on the chain that doesn't do any ICM verification, but that will seal the current epoch and force the next block that's produced to advance the epoch. And then final security consideration, this is related to the question that Meg asked, but if epochs are applied to or are implemented at the consensus layer, then any validator set changes that accrue over the duration of an epoch will all be concentrated at the boundary of the epoch. This, depending on, or if the cumulative amount of validator churn is excessive, then that could affect the stability of consensus. Yeah, as I mentioned, the epoch or the ACP in its current form is primarily targeted towards VM, inner VM applications for ICM verification purposes. So the ACP just points this out as a consideration, but we don't go into any more detail than that. Yeah, go ahead, Michael.
Yep, thanks, Cam. I was just thinking back to a conversation I was having at Avalanche Summit about this idea, and thought it was worth sharing here. Do you mind if I present over you, actually?
Go right ahead.
This is more or less how the ProposerVM currently provides a p-chain view to inner VMs, where you have the L1 blocks, the inner VM blocks on the top, and each of them contain a pointer to the latest p-chain block. Latest is kind of in air quotes because it's can be set by the block builder. It's the potentially the latest block, or at least a recent block that the block builder has seen. But with each subsequent L1 block, you can obviously have a new pointer to the p-chain. And oops, sorry, jumping ahead. That creates these two issues that you were mentioning, Cam. So the epoch view, as Cam was describing, looks something like this, where each block has a pointer to both the epoch p-chain height, which is the yellow, and the latest p-chain height, which is the blue. And the latest p-chain height is effectively following the same rules as the latest p-chain height does now, which is that it's monotonically increasing by each subsequent block builder. And the question I got when discussing this at Summit, which was very interesting to me, was why do you even need those blue lines? Why do you need these latest pointers, other than for the block that seals a given epoch, which in this case would be L5, I think, seals the first epoch here on this screen. Only that block really should need the current pchain block pointer, because otherwise it's the latest pchain block's unused. And I was like, oh, that's a great point. I bought it. I was like, maybe there's an optimization that can be made, and we only need a single pchain block height pointer except for sealing blocks. But upon further evaluation, and the person I was talking with at the time, Ron actually was the one to answer his own question. We still do need to keep these latest block pointers, even though we're not using them in any of these blocks in between the epoch, because you don't want to trust the producer of the sealing block to advance the pchain height properly. So you would here kind of bounding, each block builder gets to continue to advance what the next epoch's pchain height could be by incrementing the latest pchain block. And you still have to validate that the latest pchain block pointer, these blue lines, are strictly incrementing for all blocks throughout the epoch. That way, the block proposer, who just happens to be the one selected to propose the block that seals a given epoch, can't force the next epoch and longer duration of time to use an outdated view of the pchain. So I thought that was an interesting aspect of the design, and a very thoughtful question as to why you need 2 pointers per block now, not just for the sealing blocks.
This is a great diagram. Should consider including it in the ACP. Cool. Are there any other questions?
Hope this is one of the lesser contentious ACPs. People are definitely, we've seen want to use ICM with the increase in messages and chains sending messages on mainnet. And if we're able to decrease the gas cost of those messages across the board, seems like a solid win. In addition to anyone running relayers, seeing less errors delivering those messages. So very excited for it.
Yeah. Right now, when constructing ICM messages when constructing ICM messages from a relayer, we're just using the current pchain tip effectively and taking a best guess at, or not a best guess, but best effort at delivering that, and hoping that that validator set is still valid by the time it's delivered to the destination. And with epochs, there's just, you can provide much stronger definition of what specific height to use at any given point in time.
Thanks for sharing that, Michael. I'll include that in the notes and also in the description of the recording that eventually gets posted. Are there any other questions about ACP-181? All right, 7 seconds, according to Juan, means probably not. So thank you, everybody, for coming. It's been a great discussion. Of course, if you have any follow-up questions after this meeting is concluded, you can leave them in the GitHub discussion in the ACP repo. But as always, we'll keep you updated and see you next time for another meeting. Thank you.
Thanks, everyone.